Alright, so no school tomorrow, right? Friday's a holiday for students. So this is our last class until Monday. So I want to talk about the ODP you just did, 411. I want to talk about the last ODP for this week, which is 412. I want to talk a little more about gets and VI and tool usage and lots of good stuff like that. So questions first. So let's look at ODP 411, the parse function. So here's a sample. This is similar to what we did yesterday in class and what I posted on Canvas. It takes a car pointer and it returns an int, and we're doing the tricky scanf where we scan for two things. We ask for an integer with %d and also for a string with a %s. And then if it returns anything other than 1, there's an error, right? If it returns 2, it means there was some stuff after an integer. If it returns 0, it means it didn't find an integer at all. So if the return's not exactly 1, we can return our error code right there, which is a -1. Otherwise, it did parse an integer, so we'll check the integer to see if it's between 1 and 3, and if it is, we'll return that integer value, 1, 2, or 3. Otherwise, we'll return an error, -1. And this is not a lot of code, right? So it's useful when you're doing these ODPs. I'm not giving you these ODPs just to give you something to do, because I know you've got plenty of things to do. The point of the one-day programs is to make sure that that you understand a certain level of things up to some point, right? In this case, understanding what scanf does, how to use it to detect integers possibly with other stuff after it, and also some of the details like why do we have an ampersand in front of I and not in front of temp, right? Why do we say car temp bracket 1000 instead of car star temp, but in the function declaration we just said car star arg instead of car arg bracket 1000, right? So all of those details. So if this was a very challenging assignment, and I think it was for probably the majority of people, right? It's useful afterwards to sort of take a breath and think about, okay, so what are the takeaway messages from this assignment, right? And hopefully you're not just changing things over and over and over until it works, right? Hopefully when it works, you know why it works, and you know why it didn't work when it didn't work, okay? As opposed to just, change things around or try to make it look like what we did in class until it magically gives you 10 out of 10 on all the parts and pieces. So, so questions about this, right? I mean, this is confusing. This is confusing to almost everybody, even if nobody will raise their hand and say, I don't understand this. But if there's something that's not clear about this, yeah.
I had trouble with that int parse and then within the parentheses. I didn't understand like the syntax, right?
Okay.
And like why it needed to be in that order.
All right, so you're talking about the second line there, right?
Yes.
Okay, so let's talk about this. We're writing a function called parse, okay? And when we write a function, we have one line that basically sets up what the function is called, what it takes in as arguments, what it returns, and then we have a curly bracket somewhere. So let's just think about this, okay? So parse is the name of the function. It returns an integer. That's pretty straightforward, right? So the argument. So I think the ODP says it should accept a string, okay? Or maybe it says a car star. So what is a string? It's an array of characters. And how do we make an array? Well, usually we say either car array, right, whatever it's called, bracket, and the length of the array, or we say car star and the name of the array. Those are our two main ways. All right, there's a fundamental difference between these two declarations. When we say car array name bracket 120, we're telling the compiler array name is going to be an array, a pointer to a character, and it's going to hold 120 characters. We're telling it how big this is. And the compiler will do the following. It will look through memory and somehow find a spot where there's enough space for 120 characters, and then it will set array name to the address of that first character. So it's doing two things. It's finding a block of space to hold the array, and then it's initializing the value of array name to be the address where that block begins. When we say car star array name, neither of those things happens. All we're telling the compiler is this is going to point to a character. We're not telling it where it points. We're certainly not setting aside a block of memory. We're just saying, when you see array name, it's pointing to a character. And we're leaving it up to something else to actually give it a value.
My star is right next to car instead of the array name. Car star space array name.
Yeah, that's absolutely the same thing as this. And it's the same thing as this. So in that part of the declaration, the spaces are pretty much ignored. Yeah?
Is there a reason why it's ignored?
A lot of spaces are ignored in C. Like, for example, I could have a space after parse before the parentheses, or not. I could have a space after the parenthesis before the car, or not. So same thing with a star. I could have a space after the star or not. In fact, I think you can also do... I think if you do this, it might look like multiplication if there's no spaces. But I don't know. That's a good question, actually. Yeah, even that's fine. Just car star arg. So spaces are usually required where they're needed to resolve ambiguity. Okay, so if it's not ambiguous, the space is most likely optional. All right, so when we make, yeah, go ahead.
So the second one you mentioned, so we create a pointer array name and an array name of pointer to a car.
Mm-hmm.
And then we don't know anything about the car. We just know it points to the car.
Right, right. Yeah, so
So the car can be like just one car. It also can be like
a whole bunch of them in a string. Yeah, exactly. All we're telling the compiler here is array name is going to point to a character. So let's add some code to this. All right, so I've got an array name, which I'm declaring car array name bracket 120. I've got another array, which I'm just declaring car star another array. And I'm going to do something that the compiler is not going to like, but it will do it. Which is I'm going to print out the value of array name and the value of another array. And I'm going to print them out in hex, just because we like hex. I'm going to print them out as if they're just numbers. And remember, when you have an array or a pointer, when you have an array, array name without any brackets or anything else means the address of the first thing in the array. Okay, that's just a quirk of arrays in C. If you use the name of an array, it means the address of the first thing in the array. So let's just print out the value of array name and another array. And it'll complain, but it will still do this. So array name has this value B5B09060. It's a memory address. And if I actually looked at that address, I would see, you know, the first element of the array. Another array has a value of 0. Okay, it hasn't been initialized. And right now, things that aren't initialized seem to be initialized to 0. That's not always the case. Okay, so that's the difference between those two. So when we're writing a function, the idea is something is going to call that function. So we're going to have some main program, and it's going to do something, and eventually it's going to say, you know, integer I equals parse something which is an array of characters, right? And this could be coming from an fget. It could be defined with, you know, temp equals quote blah blah blah. It could be coming from argv bracket 1. Could be coming from a lot of different places. The parse function has no idea where this argument came from. It's just being given this argument from whoever's calling it. And so our main program says parse temp. Maybe temp is argv bracket 1, or maybe it came from fgets. This is the address of the first character in the array. Okay. We call parse. What happens? The argument of parse, arg, gets set equal to this value, which is the address of the first element in the array. So even though saying this doesn't tell us anything about, you know, what the array is, how big it is, where it points, or anything like that, when it's an argument to a function, what happens when you call a function? The arguments are given values based on who called it. So you call a function, you list a bunch of values, those values get copied into the argument's values. So that's where arg is going to get an actual value from, is from the fact that we're calling it. And as long as temp is something, you know, that's actually pointing to somewhere in memory where there's a bunch of characters, once we start running parse, arg will be the same value, and it'll point to a bunch of characters in memory. Now if we declare it like this, then we're kind of doing something. We're kind of trying to do two things. We're making an argument, but we're also saying I want this to be the address of this block of memory, and I think you'll get compiler issues there. So usually arguments to functions, if they're strings, we declare them like this. In a main program, we might say something like, let's set temp equal to be that. Does that make a little more sense? Okay. All right, other things on here that seem weird. Yeah.
Why do you need an additional case of return -1 if you already, I guess, got the return value to where if it's not equal to 1, that was the last thing that tripped me up that finally got
Yeah.
to work.
Yeah. Okay. So this is an excellent question too. So scanf, remember, it's doing two things. It's doing three things. It's checking to see if there's an integer followed by a string. If there is, it's converting the characters of that integer and storing them in I and the string into temp. And then it's returning a flag that tells us what just happened. Okay, so that first if is saying, did something weird happen? Did it do something other than convert exactly one integer? So if you say ha ha, it's going to return 0. Okay, and that's what that first if does. Okay, if we get through that if return is not equal to 1, that means return equals 1, it found exactly an integer. So if you typed in a 2, return is equal to 1. Okay, the value of that integer is in I. And part of the ODP said it's got to be the integer 1, 2, or 3. So that second check is making sure, okay, we know it's an integer. Is it between 1 and 3? If they type in the number 5, return will still be 1, so our first if fails. We go down to our second if, is I between 1 and 3? Well, that'll fail because I is equal to 5. And so now we're down to our third statement, and that's where we need to return -1, because 5 should return -1. Anything other than 1, 2, 3. So it's really checking, is there exactly one integer? is the integer between 1 and 3, and if not, then return the fail code. Does that make sense? Okay. All right, what else in here? So the only thing we haven't talked about is the scanf, which I think is the weirdest part. So scanf, right, takes 3 arguments at least. It takes the string that you're trying to convert, the string you're trying to parse, and then it takes a string of format specifiers, which says how do I want to interpret what's in that string, and then it takes a list of variables to put the results into if it succeeds in converting things. Okay, so the string we're trying to convert is the string that was passed to parse, which in this case is called arg. If we had said integer parse car star haha, right, we'd be doing scanf haha. So whatever that variable is that we're passing to parse, that's the thing that we're trying to scan. And we don't want to say star arg here, because that would say the thing that arg points to, that would be the first character. We just want the whole array or the string, which is just arg. The format we've talked about, it's an integer followed by anything. That's just to pick up an integer and see if there's something after it. And then we need a variable for each thing that we have a percent over here. So %d says scan an integer. Our integer is I. Okay, it's just a temporary variable. So we have integer I, and we have to pass the address of it. Because usually in scanf, the variable has to be specified by its address so that scanf can change it. So we're used to putting ampersands in front of these things. But the next variable, temp, we don't put an ampersand in front of. Right? Why is that? Because TMP already is an address. When you have an array, the name of the array is the address of the first element. So really, when we say TMP, it's the same thing as saying the address of temp bracket 0. It's the address of the first element in the array. And if we had said ampersand I, comma, ampersand temp bracket 0, that'll work great. But it's more confusing that way, so we just say temp. But if you just say ampersand temp, that's a totally different thing. Right? Temp is the address of the first element in the array. Ampersand temp is where that address is stored in memory. It's something completely different and usually not interesting to the code. So it feels like an inconsistency maybe, but it's just one of these things to remember. If you have a string, it's already an address. Don't put an ampersand in front. Yeah?
If you were parsing the string and it had a number, a string, then a number, are you able to discern like the different parts of it?
So if it starts with a string, like with this scanf,
Yeah.
so if it starts with a string that's not, containing a 0 or 1 or something like that, if it starts with an X, scanf will look at the first character and say, this is not, there's no way this can be the start of an integer,
Right.
and it will give up right there. And it'll return a 0 saying I didn't manage to convert anything, and it will not change the values of I or the contents of the array temp. So it quits as soon as it can no longer make any progress. It doesn't say, well, let me look further on and see if I can find an int. Right, it starts at the beginning and it just stops. And I strongly recommend writing some junk code to play with scanf. Right, and just think of as many questions as you can. What would it do in this case? What would it do in that case? And just throw some code at it. Right, it's really good practice at writing code. It's really good practice at Linux, compile and edit and run. And it will, tie up all the loose ends in your brain about what exactly is going on.
You said scanf clears the buffer after
scanf doesn't really deal with a buffer, it's dealing with a string that it's parsing. Right? So it always starts at the beginning of the string and it just tries. Now if I call scanf again, it's going to start at the beginning of the string. It doesn't matter if I called it earlier and it found an integer and that was it, right? scanf always starts with the first character of the string. That's the difference between that and scanf.
Yeah, I know.
Scanf, we're reading from this sort of internal holding buffer, and so things get used up out of that.
Yeah, and I would do some like while whatever, and
Yeah.
then get car, and then just.
Right. Yeah. So scanf is usually a little cleaner to work with. All right, and again, the I can see clearly now book has a whole chapter on scanf or scanf and these kinds of details.
So in main function, you got some words from the keyboard.
Mhm.
Stored in ARG, right?
Mm-hmm.
And then in this function, you have a temporary chart which can hold 1,000 characters. So we don't know how big is ARG. So
Yes.
is this a problem?
So there could be a buffer overrun here, right? So so this would not be safe in a sort of arbitrary, because if the argument here was 10,000 characters with no spaces, the integer would go into I and it would try to load 10,000 things into this array that can only hold 1,000. So there is a potential buffer overrun. If you wanted to avoid that, there's a few ways to do it. One way would be to take the argument that's coming in and truncate it. Right? Check its length. If its length is smaller than 1,000, don't worry about it. If it's bigger than 1,000, just put a null terminator in element 999, and now you've only got 999 characters in there, or things like that. A more proper way would be to look at the length, and then instead of saying this is a 1,000 element array, allocate this dynamically at runtime to be big enough to hold all of arg. But that gets into malloc and other stuff like that we're not ready for. That's more like winter time. But yeah, this has a potential buffer overrun. All right, reasonably good? All right, so let's go on to ODP 412. I'll show you 411 main.c because I know some people were wondering what it actually looks like. It's just that. So it prototypes the pick function. It has a buffer of 120 characters. It uses fgets to read 120 characters from standard in. It gets rid of the new line at the end, and then it calls, it prints out the value of I, which is just a counter, and then it says parse of, and it shows me the thing that was being parsed, and then it prints out the return of the parse function. So it's just a test bed for parse. And there's the actual file that drives it. So there's 4 graded tests called grade 1, grade 2, grade 3, grade 4. And grade 1 uses that set of input. And grade 2 uses an empty line. And grade 3 has something like an integer, period integer, and grade 4 has 4 integers separated by spaces. So the ODP usually has a main program and then a configuration file that shows different ways to drive it, command line arguments and or input. And so it's just trying to exercise. All right, ODP 412. So 412, we're writing a function called start. It returns an integer. It takes 2 arguments, which happen to be called argc and argv, and guess what? They look exactly like the argc and argv that a main program normally gets. Okay, so the way you want to test this is probably to write a main that takes an argc and an argv and just passes argc and argv to your start function. Okay? And what does the function do? If argc is not exactly 2, it returns an error code, -1. If argc is exactly 2, then it does one of the following. If argv bracket 1 is an integer, and it's positive, you're going to return its value. If it's not an integer, return -2. If it's an integer but not positive, return -3. Otherwise, return the value of an integer. So what is this? This is how we pick how many sticks we want to play with in the beginning of the game. If you said stick space and you put a number on the command line, this would be code you could use to see if there was a number, if there was an argument given, if that number was an integer, and if it was an integer that was bigger than 0. PA2 has got to be bigger than 10, but this is just practice code.
You need to print error like when RC is not 2.
Do not print anything, just return an integer value. So if argc is not 2, return -1. And if it's 2 but it's not an integer and argv bracket 1, return -2, and so on. So no input, no output, same as 411. But the way to test it, probably write a integer main parentheses int argc char star star argv, and then, you know, integer result equals start, and just pass argc argv from main, and then look at the value of the result. And so run your main program with different arguments, and if you run it with exactly one integer, it should print the value of the integer. Otherwise, it should print one of these error codes. And the rest is boilerplate. That's SS start, start.c. All right, does that seem doable? The trickiest part here is testing it yourself, because you have to pass argc argv to your function to see if it's working or not. But just take those from your main program. So general Discord comment here, right? I'm okay with people posting code for their test bed. Okay, I don't want you to post your ODP code. And that's not just to be a pain, right? The problem with posting code for your thing that you're trying to write is it's too easy with 20 or 30 people looking at it for somebody to say, oh, do it like this, right? And if somebody types and shows you what the right code is, your brain has seen that. You can't unsee it, right? And you're never going to be able to look at your code again and see the bug, right? You're just going to see how it should be written. Well, there is no should be written, right? There's different ways to write it. You want to discover how to write the code that functions, not what the correct code should be, so that you can change what you thought would work into what is correct, right? So that's why I don't want you posting the actual code that you're trying to make work. But if you think your code's working, but you assess it and it's not giving you a 10 out of 10, right? I'm okay if you want to do something like say, here's the test bed that I wrote to use, and here's the tests that I tried, and here's the results. And if somebody wants to say, okay, try it with an empty input line, or try it with something like 2.5, right? And then you try that and it doesn't work, so you go back and you change your code. That's fine with me. Make sense? But try to write the test bed on your own as much as possible. All right. So somewhere in Discord last night, I think it was Sam from the other section, posted under the segfault channel some different ways to format code, and probably the worst possible way to format code in terms of brackets and semicolons. And it was pretty funny. And it was a perfect setup for something we're going to do probably in about 4 weeks. We're going to talk about a program called sed. And sed is one of the tools we're going to learn, and it's a real powerhouse. It's one Unix command, but you can do a lot of things with it. And so I want to just show you a little script that I made called format. So this is a short script, right? And it runs through bin sed instead of bin bash. And it's really 6 lines of code. Some of these lines are longer than the size of my screen. But it's 6 lines of code. And I wrote this while I was eating pancakes this morning, okay? If you understand sed and if you understand regular expressions, which we're doing in a few weeks, this is trivial to write. But let me show you what this does. So here's my parse.c function. If I just say format parse.c, it turns it into this really unfortunate but still syntactically legal version of my code where all the brackets and semicolons are sitting over there on the right. So it's just a way to make your code really annoying and to sort of win any debate about what's the worst way to put curly brackets in code. And it's a 6-line sed program. That's a 4-line sed program. So that's just a little teaser of what we'll do in a few weeks with sed. And this is a good point for a video interlude. So I usually show this at some point during the course, and this is a good point because it's before a 3-day weekend. This is a 30-second video. My mantra about learning Linux is, learn a few commands, put a few tools in your toolbox that are useful to you, right? Sed is one of my go-to tools. I use it all the time for stuff like this or other stuff. Don't try to learn 1,000 Linux commands, right? There's more than 1,000 that you can learn, but learn a few that seem useful to you. How do you know if it's useful? Because you find a command and you try to use it and you figure out a few things and you sort of leave it on the side, and every now and then you might pick it up and use it for something. You might never touch it again. If you don't touch it, don't put it in your toolbox. But if you keep picking this thing up and using it, it's going to be something that's part of your toolbox, right? And it's something you're going to get better and better with. That's a tool that you probably want to dig into a little bit, find out more that it does. If you use VI, learn a little bit more about VI, right? That's what we're doing yesterday and today is going through VI commands. So it's not how many tools you know, it's how well you know your tools, whatever that set of tools is. So this is probably the best video I've found about this. So tape measure masters. Right, so know your tools. All right, let's see. Last thing I want to talk about before back to VI is gets. So we talked about gets a little yesterday. We said gets is dangerous, it's deprecated, and so on and so forth. Let me give you an example of what you can do with gets. So I've got some code here, okay? I've got some integers declared. I've got a super secret password, 19, don't tell anybody. I've got a character array called answer. And first thing we do, we ask the user if they want to continue running this program. So do you want to continue? They say yes or no. And we use the dreaded gets to read their answer, okay? So they'll type in a yes or a no. And if answer bracket 0 is n, if they type in anything that starts with an n, we'll just exit the program. Otherwise, we say enter the password. And we let them type in an integer, and we store it in user PW. And if user PW is different from password, we kick them out. Okay, they're not authorized. Otherwise, they put in the correct password, so we say welcome, and we transfer all the money that we have to their account. All right, pretty straightforward program. And 19 is something more interesting, something they can't just guess. And so we can compile this, and normally if you just compile this with GCC on this machine, it will prevent gets from doing bad things. It'll add extra code to check for a buffer overrun. Okay, so I've got a version that just adds a switch which says don't add this protection to the stack. It's stack smashing. So I can compile that. So let's say go. Okay, so do you want to continue? Yes. and you put in your password, and if you know the password is 19, you're good to go. Okay. Do you want to continue? Yes, put in the password, I don't know, 25. It says you're not authorized. Pretty straightforward program, right? Okay. Do you want to continue? Yes. Is the password 65? No. But I like 65. It's my favorite password. It's the password for all my accounts, right? So here's what I do. Do you want to continue? I'll type Y, but I'll also type some other stuff. What's the password? 65. There you go. So what did I do? I just hacked my little program. And how did I do that? Because answer is set up to hold 2 characters, and I typed in a Y, a space, and A, and enter, and there's a null terminator at the end. And that filled up memory starting at answer. This took 2 of those characters. Where'd the other characters go? They went into this integer, because that's what's sitting next in memory. And I changed the value of integer password from 19 to 65, because 65 is the ASCII code for the letter A. And so now when I typed in my password of 65, it compared that to the value of password, which was 65. So I basically changed the code while I was running it just by typing in the right thing. That's a classic buffer overrun scenario. So it's not that hard to do in theory. Now, like I say, if I just compile this, and do you want to continue Y space A? Oh, it's still, okay. So, so it actually detected that something bad happened. Okay, so that stack protection switch on GCC will stop this from running. But if you compile it with a different version of GCC or different default switches and so on, you may be able to just overwrite what's in memory. All right, let's see. We got 10 minutes. We can finish talking about VI. So we talked about removing text, right? And if I want to delete 4 lines, I can say 4DD. It'll delete 4 lines. And we talked about pasting. Okay, so that's in the paste buffer. So if I go to the beginning and I hit a Shift P, it pastes what's in the buffer before the cursor. So in this case, I put my comments up top. So P will paste after the cursor, Shift P will paste before. This is a sort of common motif. Lowercase comes after, uppercase comes before. And we can also put stuff in there explicitly by doing a Shift Y. So Y will yank a line, number Y will yank that many lines without deleting. Okay, so we finished with changing case. So if I want to shout, I can just hit a tilde and it will change whatever the current character is to uppercase if it's a character. So I can change my code to, my comment to uppercase. If I try to change the case of a dash, it's not going to do anything. Right, spaces won't do anything. And so on. And if I were to just sort of lean on a tilde and let it repeat, it toggles everything between uppercase and lowercase. And if I didn't want to do the auto repeat, right, I could say 100 tilde, and it does a tilde 100 times. And each time you do tilde, it also moves over 1 spot. So that's a quick way to change the case of everything on a line. That's not something you use very often, but once in a while you need to do that, and it's kind of a nice trick to have. All right, I think we talked about Control G, shows you where you are. So if I go over here and I hit Control G, tells me the name of my file. It tells me it's been modified. I haven't saved my latest changes yet. I'm at line 8, there's 154 lines in the file, I'm 5% of the way through the file, and I'm in column 6, ECHO space quote. So Control G is useful, tells you everything you need to know about where you are. If I go down to the bottom, line 154, 100%, and so on. Another useful command is Control L. Control L is a refresh, and this is standard throughout a lot of things in Linux. It updates your display and resets it. In case something happens, you get an email message and it suddenly appears in the middle of your window, right? It will pick that up. So you can do who, and you can see who's logged on, and I can say, oh, let's see, oh yeah, Nick's logged in. So with great power comes great responsibility. So there's a command on here called write, which I can say write Nick, and it'll tell me I'm getting a message from tested localhost. And I can say hello Nick, and it'll show up in the middle of my window over here. Right, so there's a way to send messages from user to user, which is kind of a pain if you're in the middle of an editor and you're working on a file and you walk away and you come back and your file looks like this, right, because someone's writing to you. It's not changing your file, okay? It's just appearing on your screen. So if you want to refresh your screen, right, Control L just redraws everything. So you can get rid of that. If you don't want to be talked to, you can say MESGN, and then if somebody tries to write to you, it'll say messages have been disabled. So if you're in the zone, you don't want to be bothered, just MESGN turns that off. Alright, so Control L is a refresh. That's a useful one to know once in a while. U is an undo. Okay, it undoes your last change. Uppercase U undoes everything that you've done on the current line, but it only works while you're on that line. If you move off the line, you can't do the big U anymore. So if I come in here and I do a bunch of tildes, and I change some stuff, if I do a U, it just undoes my last change. If I do a Shift U, it undoes everything I did on that line. It's like a super Control Z. And the behavior of that changes from machine to machine. Okay, colon brings you down to a separate spot in your window, down to the lowest line, and it takes a separate command, and there's a whole bunch of commands you can do from here. So for example, welcome to my matchstick game. So I could say colon substitute space with underscore everywhere on the line. And now all my space is turned into underscores. Or I could change a double quote to a single quote everywhere on my line. And now my double quotes change to singles. And if you don't say /G, it'll just do the first occurrence of it. So if I say substitute a space with, A, it just changes that first space. And this is back into regular expressions. This is something we'll spend a separate unit talking about, but it's a way to do quick substitutions. I can say colon VI, and I can put in the name of a file, and I can switch to editing another file. And if I want to go back and forth, I can do Control 6, and go back to my first file or my second file. And that can be useful sometimes for hopping back and forth. I can do commands. I can say : what directory am I in? Oh yeah, I'm in home Nick. Oh, what was today's date? Oh yeah, it's October 10th. All right, so : followed by any Unix command executes that Unix command.
Can you show how to change the file again?
:vi and whatever the other file is. File 2. File 2 doesn't exist. And if I want to go back to the first one, I can just do Control-6. And it goes back to the first file. It's actually Control-, but it's the 6 key. I can read the contents of a file into my current file by saying : read. Let's say I want to read the contents of file 2. I can say : r space file 2, and it'll read the contents of that and paste it into my file right here. So maybe you have a block of comments that you use over and over again, throw that in a file and just say : r, and it'll pull it in for you. So written on, I would like to add current date and time right here. Well, I know I can say : date, and I can see the date, and then I can type it in, right? I can actually say : read the output of a command, like date, and it'll execute the command, and it'll put the output of the command right here. And an uppercase J will join the current line to the line that follows it. So if I move up here and I hit a J, it says written on, and there's the timestamp. All right, and saving and exiting, :W says write my file out. Okay. :Q says just quit, don't bother writing my file. :WQ says write my file and then quit. If you haven't made any changes to your file, just :Q. Right? If you :WQ or :X and you accidentally deleted a line, you've just saved that as your current file. So if you don't think you've made any changes, just :Q. Now, if I accidentally deleted a line and I try to say :Q, it'll say you haven't written since the last change. If you actually want to get out, :Q exclamation. All right, and last one I'll show you here just because it's really fun. :split gives me two windows on one display. And Control W will switch between one and the other. So down here, maybe I'll switch to file 2. Right, and I can be typing stuff up here, and Control W brings me up to my first file. And it's a whole little window. It's half-sized, but you know, you can move up and down and so on and so forth. But it's a nice way to sort of go back and forth between two files. Now, I usually just open two files on my window. If you have a big monitor, you've got lots of real estate. But if you're real estate constrained, you can do it in one window like this. And if I exit one of these, right, then my screen grows back and I'm just editing one file. All right, so there's some extra stuff for VI. Like I say, the goal is really just to have some options to play with, make a note of them, try them once in a while, and see which ones you end up using a lot, which ones your brain likes, and build up a toolkit like that. All right, so have a good 3 days. I will see you on Monday.
Which one did you say you read in the file?